Alright, for number one, you are using the triangle on the right to help set up the trig proportions. You're not actually solving for anything, you're leaving the ratios and the proportions as fractions. Remember with trig, an easy way to remember which trig functions go with which sides. You've got SOHCAHTOA. Sine goes with the opposite side and the hypotenuse. Cosine goes with the adjacent side and the hypotenuse. And tangent goes with the opposite side and the adjacent side. Looking at this right triangle, we have two sides. So first we have to figure out what the third side is. You can do that using Pythagorean theorem. X squared plus 24 squared is equal to 25 squared. 24 squared is equal to, I don't remember, 24 squared is equal to 576. 25 squared is 625. You're going to subtract 576 from both sides. You're left with x squared is equal to 49. And then you take the square root of both sides, leaving you with x is 7. So now you have a right triangle with sides 7, 24, and 25. So setting up each proportion, you're looking at sine of angle A. So we're looking at this angle right now. Sine is opposite, so the opposite side to A is 24 over hypotenuse, which is 25. So you've got sine of A over 1 is equal to 24 over 25. Cosine of A, so you're still looking at this angle, is the adjacent side, which is 7 over the hypotenuse, which is 25. So cosine of A over 1 is equal to 7 over 25. And the last for angle A is tangent. Tangent is the opposite side and over the adjacent side. So tan of A over 1 is equal to the opposite side over the adjacent side. So we've set up the three proportions that represent angle A. Angle C, you're now looking at this angle up at the top. So in green, angle C. So now you're going from this angle, the opposite side would be 7. The adjacent side would be 24 and the hypotenuse would be 25. So if you're looking at sine, which is the opposite over the hypotenuse, the opposite side is 7. The hypotenuse is 25. So sine of C over 1 is equal to 7 over 25. Cosine of C is the adjacent side, which is 24. So cosine of C over 1 is equal to 24 over the hypotenuse, which is 25. And last, you've got tangent of C, which is the opposite side over the adjacent side. So tangent of C is equal to the opposite side over the adjacent side. Okay, so those are the 6 proportions for trig that you could set up using the triangle to the right. For numbers 2 and 3, you're just telling me what the sine of 56 is equal to. So you've got your calculator. You want to make sure that it is in degree mode. So shift menu, go down to angle just to make sure that this part says DEG. It doesn't. So you're going to hit F1. So now it's in degree mode. Alright, so exit back to the main screen. And we're going to do sine of 56, enter, okay, 0.8290. So 0.8290, alright, is what is equivalent to sine of 56. Alright, tangent of 87. Tangent of 87, enter, is 19.0811. So 19.0811. Alright, so those are the what each trig function is equivalent to. Alright, 3 is a little different because you have the cosine of x is equal to this decimal. Now remember, x is an angle. So if you're looking for the angle that's attached to the trig function, you have to do the inverse trig function to get the angle. That means you have to take cosine to the -1. This is your inverse function of 0.4384, and that will tell you what x is equal to. To get the inverse of cosine, you're going to hit shift cosine, so now you've got the cosine of -1, and you are going to put your decimal 0.4386, hit enter. Alright, so the angle degrees for angle x is 63.99. So if you took the cosine of 63.99, you would get 0.4384. Alright, number 3 is similar. Instead you have sine, so you're going to take the inverse sine function of 0.5299, and that will give you what y is equal to. Alright, so you've got shift sine, parenthesis, 0.5299, hit enter, and you get 31.999. Okay, and that's degrees, so it's measure of angle y is 31.999 degrees. Alright, number 4. So now we have a right triangle and we're trying to figure out what angle y is and what angle x is. We have two sides of a right triangle. We could figure out what this side of the right triangle was if we wanted to by using Pythagorean theorem, but we don't need to. So we're going to start with choosing angle y. You could start with angle x if you want. I'm just choosing angle y. Alright, so I have angle y. Across from angle y is 4. That's the opposite side. And 17 is the hypotenuse across from the 90-degree angle. That's the trig function sine. So you've got sine of your angle, y, over 1 is equal to the opposite over the hypotenuse. So 4 over 17. Since we're trying to solve the angle just like we did in problems 3 and 4, you have to do the inverse function of your answer, 4/17, and that will get you what angle y is. So we come back up here. We're going to type in shift sine to get the inverse of 4 fraction button 17, and that gives me 13.61. So your angle for angle y, the measure of angle y, is 13.61. So now that we have this angle in our triangle, we know this angle is 90. To find out what the last angle in the triangle is, you could just do all the angles add up to 180 degrees. So you've got 180, take away 90, take away the second angle, 13.61, and that leaves us with the measure of angle x is 76.39 degrees. So now we figured out all the variables in that triangle. Alright, number 5. You're looking for the hypotenuse of the triangle and you're looking for this angle. So first we'll start with looking for the angle. Looking at this angle, we know the opposite side is 16. This is the hypotenuse, and this side is the adjacent side. So if we're looking at this angle, we're not using the hypotenuse because we don't have any value for that. And we do have a value for the opposite and adjacent side. So you're going to use tangent, because that's the trig function that goes to the opposite and adjacent side. So tangent of x over 1 is equal to the opposite side 16 over the adjacent side, which is 22. Since you're looking for the angle again, you're going to do the inverse trig function of 16 divided by 22. Pull the calculator back up. Okay, so shift tangent, parenthesis, 16 fraction button 22. Hit enter. So it tells us measure of angle x is 36.03 degrees. In order to find z, which is a side, since you already have two sides, you can just use the Pythagorean theorem. So you've got 16 squared plus 22 squared is equal to z squared. In the calculator, I'm going to do 16 squared plus 22 squared equals, so you've got 740 is equal to z squared. Take the square root of both sides. And you get 27.02. Now, normally, and I'm sure Ms. Gelios would agree, you should be simplifying this as simplifying the radical. So either making the tree or dividing by higher perfect squares. Since this is part of the trig function, for right now, I'm going to accept a decimal for that answer. But I believe the answer would simplify to 2 times the square root of 185. Alright, the last two on this page. Number 6. You're looking for angle y, and you're looking for the hypotenuse of the triangle. Well, you already have two angles of the triangle, so it should be easy to find out angle y, since they all add up to 180 degrees. So I subtracted this 90, subtract the other 25, leaves us with 65. So you've got angle y is 65 degrees. Alright. Okay. Angle, or not angle x, side x. Well, we have this angle that we definitely know is correct because we were given that angle. So we're going to use 25, which makes this side the opposite side, and we're looking for the hypotenuse. So the trig function that goes with O and H is sine. So you've got sine of the angle over 1 is equal to the opposite side of 4.6 over x. Since we already have the angle, we don't need to use the inverse trig function to find the angle. So now we just have our proportion. In a proportion, you cross multiply. So it's sine of 25 times x is equal to 1 times 4.6. Since you're solving for x, you want to get x by itself, so you're going to divide both sides by sine of 25. So in the calculator, you're going to take 4.6, divide sine of 25, and you get x is equal to 10.88. So that is the length of your hypotenuse. Alright, number 7. You're not looking for any other angles. You could find this angle easily since a triangle is 180 degrees, but you don't need it. Instead, you're looking for side z and side x. So you have angle 39. Across from 39 makes z the opposite side. 15 is your hypotenuse, which makes x your adjacent side. So let's solve for z first. You've got the opposite side, and you're looking for the opposite side, and you've got the hypotenuse, so O and H. That trig function is sine, so sine of the angle over 1 is equal to the opposite side over your hypotenuse, which is 15. Again, you already have the angle, so you don't need to use the inverse. So you cross multiply. 15 times sine of 39 is equal to z. Since it's already equal to your variable, in the calculator you are going to hit 15 sine of 39, hit enter, and you get 9.44. So z is 9.44. Alright, now you have z and another side of 15, so you could use the Pythagorean theorem to find the third side of the right triangle. We're going to use trig here, just in case we would have got maybe, because there's a chance that you could get this side wrong, and then if you use the Pythagorean theorem, you could also get this side wrong. So we're just going to use another trig function. We've got the adjacent side we're looking for and the hypotenuse. The trig function that goes with that is cosine. So cosine of 39 over 1 is equal to the adjacent, which is x, over the hypotenuse of 15. Cross multiply, 15 cosine of 39 is equal to x. Pull up your calculator. 15 cosine of 39, hit enter, gives you 11.66. So x is 11.66.